Alright, so this is the video for one-step equations preview. We know that an equation is anything with an equal sign, so it's an expression like 3x, but it has an equal sign, so it would be like 3x equals 9. So what we're going to do today is figure out what those x's equal. We're always solving for the variable. Now, just by looking at this, you can probably tell that 3 times, well, we don't know, equals 9. Well, that 3 times 3 equals 9. But it's going to get a little more complicated when we involve negatives, fractions, and maybe decimals. So please listen and pay attention as I go on during the video and fill in anything that I am filling in. If you have questions at any time, please raise your hand. Make sure you're listening and following along. Remember, at any time you can pause the video, rewind, fast forward, what have you. Alright, so one-step equation notes. Things to remember. The very first thing I want you to write is that it is our goal to get the variable, which again is that x, y, whatever letter or symbol, variable alone. So we're isolating the variable. Isolating means getting alone, like an island isolate. We're getting that variable alone. So in order to do that, we have to use the inverse operation. Inverse meaning opposite. When we talk about the inverse property of addition, we know that a positive 4 plus a negative 4, those are inverses or opposites, gets me 0. Kind of same thing we're going to be doing with one-step equations, looking at the inverse operation in order to cancel it out. And finally, just an important reminder, this is an equation, so we must keep it balanced. What we do to one side of the equal sign, we must do to the other. So just like this little balance up here. So if we subtract 4 from one side, from this side, we also have to subtract 4 from this side so that it remains balanced because it's an equal, or it's an equation, and two things on both sides of the equal sign are equal to each other. Okay, so the very first thing, when you're looking at this equation here, x plus 13 equals negative 7, we can ask ourselves, what are x and 13 doing right here? Well, they are adding, right? X and 13 are adding to each other. So if you see addition, we know that we need to do the inverse of addition, which would be subtraction. So we're going to subtract, and I wrote opposite of adding, the constant, which remember is the number that stands alone, so the 13, from both sides of the equal sign. Okay, so let's do that together. My first thing I want to do is I'm going to draw a little line to separate both sides of the equation so that I know that what I do to one side I'm also doing to the other. So x plus 13, again, those two things are adding. So in order to get x alone, which is my goal, I have to subtract 13 from this side, and if I do it to one side, I also have to do it to the other. Okay, so looking at this spot right here, 13 minus 13. 13 minus 13 is, again, the inverse property of addition, so those cancel out. So I'm done with that. All I'm left with on the left side of the equation is that x, which is perfect because that's what I want. My goal is to get the x alone, because these are just one-step equations, so it's only involving one step. Then I have to simplify on the right side of the equal sign, negative 7 minus 13. Well, they're both negatives, they're going to build, and I'm going to end up with a negative 20 as my answer. Now, the second part to it, you know it's one-step equations, but you always want to check, right? We solve for x, and in our last unit, or in our last lessons, we were talking about substitution. How if I know what x is, which I do, it's negative 20, I can put it back into the equation and double check. So if x equals negative 20, let's try to plug it into this equation. So since I know what x equals, I'm going to plug it in for x, right below it, plus 13, use the original equation, and see what I get. Negative 20 plus 13 is, well, they're going to battle, and negative's going to win, and they're 7 apart. So negative 7 does equal negative 7, so it's a check. If you ever got like negative 3 and the answer was supposed to be negative 7, that would obviously be not correct. So you want to go back and try the equation again. But we got something that worked. So let's try subtraction. So again, we look at our equation. It says x minus 5 equals negative 2. Those two, the x and so the variable and the constant, they are subtracting, right? X is or 5 is subtracting from x. So if they're subtracting, we want to do the opposite or the inverse. What's the opposite of subtraction? Addition. So in this problem, instead of subtracting, we're going to add the constant, which is negative 5, from both sides of the equation again. Okay, I'm going to draw that line, and I'm going to say, well, x minus 5, I'm going to add 5 to both sides. So I'm left with x on this side, just because negative 5 and positive 5 cancel out, and negative 2 plus 5 is a positive 3, so x equals 3. Second thing I want to do is check. All right, x equals 3. Let's plug it into our original equation to double check we get negative 2. So I'm going to take that 3, and I'm going to plug it in wherever I see an x. 3 minus 5. And 3 minus 5 is negative 2. So negative 2 equals negative 2. That's a true statement. That's my check. If you need to pause it and take some time to process this, you can. Otherwise, we're going to move on to multiplication. So multiplication, when we think about multiplication, the opposite of multiplication is division. Remember, I have a little note for you on the left side that a coefficient and a variable side by side are multiplying. So if I look at negative 4 and x, I know that they're multiplying. So in order to get x alone, which is my goal in one-step equations, is I have to divide. Now this time I'm not dividing the constant, I'm dividing the coefficient. So divide both sides of the equal sign by the coefficient. It's really important that you not only divide by 4, but by negative 4, because that number is not 4, it's negative 4. So I'm going to divide. In order to show division, I'm going to draw a division bar underneath both sides of the equal sign. And you can still draw the line if you want. And I'm going to say, well, I'm going to divide by my whole coefficient on the left side, and if I do it on the left side, I also have to do it on the right side. Looking at the left side, a negative 4 of your coefficient divided by a negative 4, negative 4 divided by negative 4, you don't have to write that, is 1. So I'm done on that side. There's 1x, so I'm left with just x. Negative 4 divided by negative 4, I'm just left with x. That's all that's left over there. And then I'm going to simplify on the right side of the equation. 12 divided by negative 4 would be a negative 3. Okay, and if I want to go ahead and check, I'm going to say, well, my x is negative 3. Let me plug it into the original equation. Negative 4x equals 12. So negative 4 times, remember, coefficient and variable next to each other, we are multiplying, and we have to plug it in parentheses. Okay, and negative times negative is a positive 12, so 12 equals 12. If we are doing an equation with a fraction, when the coefficient is a fraction like it is in this problem, you're going to have to multiply by the reciprocal. So these ones can get a little bit tricky, but you can totally do it. It's just going to take practice. So if it's 2/3 times x, those two things are multiplying, we're going to multiply by the reciprocal. So the reciprocal of 2/3 is 3 over 2. Now this works out because 3 over 2 times 2 over 3, we multiply straight across. We get 6 over 6, because 3 times 2 is 6, and 2 times 3 is 6. That reduces to 1. All right, so we're left with just x on the right side of the equation. This cancels out, so I'm left with just x. And what I do to one side, I have to do to the other. So I'm also going to multiply by 3 over 2 on the right side. So if I do negative 8 times 3 over 2, it's usually helpful to put a 1 underneath that 8, because remember, it doesn't change the value. Negative 8 divided by 1 is still negative 8. So now we can multiply straight across. So negative 8 times 3 is negative 24, and 1 times 2 is 2. So we have x equals negative 24 divided by 2. But we can simplify that further, because negative 24 can be divided by 2. So my final answer would be negative 12, because negative 24 divided by 2 is negative 12. Now we have to check. So 3, oops, not 3. Sorry about that. So 2/3 x equals negative 8 when x equals negative 12. So let's check. 2/3, plug in that x of negative 12 equals negative 8. Okay, so 2 over 3 times negative 12 over 1. Multiply straight across, and we get 24, negative 24, because 2 times negative 12 is negative 24 over 3. And what is negative 24 divided by 3? It is negative 8. So we'd say that that is a check. I know you probably don't have enough room to do the fractions, or you might. I just wrote really big on this. But if you need any extra paper, just let me know. And our last one is division, okay? So if you look at this problem in the equation, x and 5 are being divided. We know that because there's a division bar, or a fraction bar. So the opposite of division would be multiply. In this problem, we're going to multiply both sides of the equal sign by the denominator. Okay, so I'm going to look at x over 5. The denominator would be 5 on this side. So remember, what I do to one side, I have to do to the other. We're going to say that a lot. So if I'm going to multiply one side by 5, I also have to multiply the other side by 5. We're left with x on the left side equals, well, what's negative 5 times 5? A negative 25. And then you always want to check. So if x equals negative 25, we're going to plug it in to the original equation. We're going to say negative 25 divided by 5. Well, what does that equal? It equals negative 5, which is what my original equation was stating. So negative 5 does equal negative 5. All right, so what I want you to do is go on to the back. The questions are always going to ask, what is the inverse operation? So for number 1, make sure you think, well, what are x and negative 15 doing? Well, they're subtracting. So the inverse operation would be addition. That's just to remind you that you, in order to get x alone, need to be adding, right? So we're going to add 15 to both sides. And then you can continue the process. Make sure you check, right? Plug whatever you get for x in to the original equation. And then just one more reminder on number 2. This is something new, so you want to dump doubles before solving. So if you look at this equation, we have negative 14 equals x minus a negative 2. Take a look at those two negatives. Before you do anything, let's go ahead and dump them. That'll make it simpler for you. That way you're just saying, oh, well, they're adding. So the inverse operation would be to subtract. So we have to subtract to get x alone. All right, go ahead and try the next few problems. And if you have any problems or you want help, just let me know. Awesome job. Keep it up.